Guys, this is a mini whiteboard type activity, or it would be if you were in school. So the purpose of this is when you get to doing the worksheet, which I've set for you, you're going to need to pick out the correct theorems, and you're going to need to be able to spot them when they're being combined with other theorems. And then you're going to be able to, need to be able to use the theorems to work out the missing angles. So what I've done here, so I've listed the theorems on the right, and there's a missing angle or multiple angles in the question. So this is question 1. What I want you to do is, for every one of these questions, is pick out the correct theorems that apply, could be more than one, and then work out the angle. So here, pause the video now, and I'll show you the answers in 2 seconds. Okay, so here I can see I have a quadrilateral. I also have angle at the center, an angle at the circumference. So this angle and this angle go together, but I also know that this angle and this angle go together. Now, obviously, I don't know this angle, but I can work it out. This is going to be, if this is 100, so angle at the center is twice the angle at the circumference. That means this has to be 200. And then I know angles around a point add up to 360. So 360 take away 200 is 160. So the theorems which I applied are this one and this one. Now, strictly speaking, I didn't really use this, but I'm highlighting this because when we say a cyclic quadrilateral, this is not a cyclic quadrilateral because that vertex is not on the circumference. However, we can use it, for example, to work out this angle here. And some questions might ask you to do that. Question 2, pause the video, pick out the theorems, work out the angles. Okay, answers in 3, 2, 1. So here you should have spotted, if I draw a line across there, I have a segment. If I have a segment, well, the angles in the same segment will be equal here. And if I draw a line across there, then this becomes my segment. And then I can say this angle and this angle will match. So in this case, I can immediately work out this is going to be 70 degrees. And the theorems I'm using are angles in the same segment are equal. Next question, pause the video now. Answers in 2 seconds. Okay, here's the answers. You can see that this is a tangent. Here's another tangent. Here's a radii. So that means that has to be 90 degrees. That has to be 90 degrees. And also we have a quadrilateral. It's not a cyclic quadrilateral, but it's still a quadrilateral. You know the interior angles add up to 360. So that's 90 plus 90 is 180. So 180 plus 65. And then I do 360, take away that. So 360, take away 180, take away 65. Gives me 115 is my missing angle. So the theorems we used are tangent and radius is 90 and angles in a quadrilateral, not cyclic. So it's not this one here. We're not using that one. When you get to the questions, the worksheets, you're going to not only need to show you're working out, but you're going to actually need to write out any theorems that you're using. Okay, next question. Pause the video here. Okay, here's the answers. You see that you have a triangle in a semicircle, so that has to be a right angle. So we might not be able to work out each individual one yet, but that's 90. That means that this angle here is going to be 180, take away 90, take away 20. So 180, take away 90, take away 20 will give you 70. 70 degrees is what should appear here. It's not going off, so you can just label it 70. Now, on a side note, if you're asked to work out this angle here, well, if you know that's 70, well, that has to be 70. That's going to be 20 because that has to add up to 90. And then you can use isosceles triangles to work out the missing angles. The rules that we have used are... All right, it's working now. So the rules that we've used are angles in a semicircle are 90 and two angles in an isosceles triangle are the same because that's going to be 70. Okay, That should be right. My computer's being a bit dodgy, so that's the angle there. Okay. Next theorem. Okay, pause the video here. Okay, going through the answers. So we can see we have angles in the same segment here. That means that this angle here and this angle here have to be the same. We can also say for this, we have these two lengths are the same, so that's given to us in the question. So that means that this angle here has to be the same as that angle there. So if you look at this triangle, that's going to be 180, take away 116, divided by 2, because it's an isosceles. So that's going to be 32. That's going to be 32. And then as we figured out at the beginning, this is the same segment here. So that's also going to be 32 degrees. And these are the theorems that we used. Okay, pause the video here, have a go. So, doing this together. This is a radii, and this is a tangent. Now, technically, I've taken some information off this question, but you would be told that this is a tangent. You can't assume it's a tangent, but in this case, I've edited the question. So this has to add up to 90 degrees. This is a 90-degree angle. So then you do 90, take away 56, which gives you 34. You also know that this is an angle at the center, and this is angle at the circumference. So you do 130 divided by 2. That will give you 65. You now know this angle here, because this angle is around a point. So 360, take away 130, is 230. And then if I just sketch the shape out here, you can see it's a 1, 2, 3, 4. It's a quadrilateral. So all of these are going to add up to 360. So there's only one missing angle there. So that's 34, 65, 230. So then you do 360, take away those three angles. So 360, 360, take away 230, take away 65, take away 34. So that should be 31. Now the rules that we use, well, we use angles in a tangent and a radius is 90. Angle at the center is twice angle at circumference, and angles in a quadrilateral. Right, I'll see you in the next video.